When we hear the word shock, our minds usually jump to a surprise party or maybe a jolt of electricity. But in the medical world, it means something way, way more serious. It's a life or death condition, a true moment of truth for the human body. So what is really going on inside the body at that moment? How can this incredible machine, so perfectly tuned for survival, suddenly find itself on the very edge of total collapse? Well, that's what we're going to unpack today. Let's dive into this critical emergency. All right, let's get right to it. At its heart, shock isn't about one single organ just giving up. No, it's about the failure of an entire system, the one system that's responsible for delivering the one thing our cells absolutely cannot live without: oxygen. So in simple terms, it all comes down to one word: perfusion. That's the delivery of oxygen-rich blood to tissues. Shock is a catastrophic failure of perfusion. When tissues and organs get starved of that oxygen, cells start to die. And when cells die, the body starts to shut down. Okay, to really get a handle on this, I want you to imagine your circulatory system as a kind of high-stakes plumbing network. Its one and only job is to move a precious fluid to every single part of the most important building in the world: your body. So every plumbing system has three critical parts, right? First up, you've got the pump. In our bodies, that's the heart. It's this incredibly powerful muscle that works non-stop, pushing the fluid through the whole network. If the pump fails, the entire system is in jeopardy. Next, of course, you need the fluid. For us, that's our blood, the amazing stuff that carries all the oxygen and nutrients. It's simple, really. If you don't have enough fluid in the system, the pump has nothing to move, and the pipes start to run dry. And the last piece of the puzzle? The pipes. These are your blood vessels, this vast, complex network of arteries and veins that carry blood exactly where it needs to go. If these pipes suddenly get way too wide, or if they spring a leak, the pressure just collapses and the fluid can't get to where it's needed most. So, if we're sticking with this whole plumbing idea, it makes perfect sense that the system can break down in a few different ways. And that's exactly right. Doctors and medics group these breakdowns into four main types of shock, all based on which part of the system, the pump, the fluid, or the pipes, is the first to fail. And this table, it lays it all out beautifully. See how it maps perfectly to our analogy? You've got hypovolemic shock, that's a low fluid problem, like from severe bleeding. Then there's cardiogenic shock, a classic pump failure, maybe from a heart attack. Next is distributive shock, a pipe malfunction, where those vessels just get too wide. And finally, obstructive shock, which is exactly what it sounds like. A physical blockage is literally stopping the flow. Let's just zoom in on that distributive shock for a second, because it's a really interesting one. The problem isn't that you've lost blood. You have plenty of fluid. The problem is that your pipes, your blood vessels, have suddenly expanded so much that there isn't enough blood to fill them up. The pressure just tanks. This is what's happening during sepsis, or a severe allergic reaction like anaphylaxis, or even some specific kinds of spinal cord injuries that mess with the nervous system's control over those blood vessels. But here's the incredible part. When one of these breakdowns starts to happen, your body doesn't just sit there and take it. Oh no, it sounds the alarm and launches a whole set of sophisticated, pre-programmed emergency protocols to fight back and try to fix things. Think about this. Right now, in a healthy adult, the heart is pumping about 5 liters of blood every single minute. That's your cardiac output. That's the baseline, the magic number the body is always trying to maintain to keep you alive. Now, imagine a serious injury. You start losing blood. All of a sudden, there's less fluid in the system, the amount of blood the heart can push with each beat drops, and your total output might plummet to, say, 3.5 liters per minute. That is a critical drop, and the body knows it. So, the body's alarm bells are ringing loud. It knows it has to get that flow back up to 5 liters a minute, or the vital organs are in big trouble. The question is, how does it do it? Well, it has a couple of brilliant tricks up its sleeve. First, it does some really smart, simple math. Your body knows that cardiac output equals stroke volume. That's the amount of blood per beat times the heart rate. So, if the stroke volume has dropped because of blood loss, what's the only other variable it can change? The heart rate. It cranks it up, making the heart beat faster to make up for the lower volume. This is why a fast pulse, tachycardia, is one of the absolute classic signs of shock. And its second trick is all about priorities. The body says, okay, we're in a crisis. We need to get the remaining blood to the most important places: the brain, the heart, the lungs. So it starts squeezing the pipes, the blood vessels in your skin, your arms, and your legs, essentially shutting off blood flow to the periphery. This is why people in shock get that cool, pale, clammy skin. It's a visible sign that the body is in full-on survival mode. And for a while, this works. It's amazing, really. The body compensates, fighting with everything it's got to keep that blood pressure up and keep the core organs alive. But it can't keep this up forever. There comes a tipping point. This is where we get to the two crucial stages of shock. First, you have compensated shock. This is when the body is fighting hard, and for now, it's winning. The heart rate is high, breathing is fast, but the blood pressure is holding steady. But then, if things don't get better, you slip into decompensated shock, and that means the body is losing the fight. All those emergency systems are starting to fail, and the one critical number that was stable, the blood pressure starts to drop. That's the tipping point.
We've all seen a blood pressure reading, right? Something like 120/80. The top number, the systolic, is the pressure when the heart is squeezing. The bottom number, the diastolic, is the pressure when the heart is resting. That gap between them is really important. Now watch what happens in shock. It's such a subtle but important clue. As the heart struggles, that top systolic number starts to fall. But at the same time, remember how the body is squeezing all the pipes? That actually makes the bottom diastolic number creep up a little. The result? The two numbers get closer and closer together. Medics call it a narrowing pulse pressure, and it's another telltale sign that the body is losing its grip.
And this is where things can get really, really dangerous. In cases of severe trauma, once the body starts to lose this battle, it can trigger a terrifying, vicious cycle, a cascade of failures where each problem just makes the next one worse. It has a pretty terrifying name, the trauma triad of death, and it's this brutal domino effect. First, without good blood flow, the body can't stay warm, so you get hypothermia. Second, as tissues starve for oxygen, they produce acid, so the blood becomes acidic. And third, that cold, acidic blood can't clot properly. So now, not only are you in shock, but your body has lost its ability to stop the very bleeding that might have caused it. It's a downward spiral that is incredibly hard to pull out of. You know, it really is a moment of truth. It's this fascinating and frankly terrifying look at the body's own internal crisis management system. It's a desperate battle, pitting these incredibly robust emergency protocols against a complete and catastrophic system failure. So when you boil it all down, understanding shock is really about understanding the fragile, delicate balance that keeps every single one of us alive. It shows us a system that is brilliantly, beautifully designed for survival, but also a system that can be pushed beyond its absolute limits. It really makes you think, doesn't it, about that incredibly fine line between the body's amazing resilience and its ultimate fragility.